Welcome everyone. In this video, we will solve a GATE 2020 EC question in which we have to find out the Vout. Okay, so in this question, given the considered a CMOS circuit in which substrate are connected to their respective sources. So we are not showing the substrate connection and the WL ratio of the transistors for the Pmos is 5 and for the Nmos is 1 which are given, and the gate oxide capacitance is same the question, and the p channel MOSFET, that is our the upper one, this one is our PMOS, has the threshold voltage -1 and the mobility, that is our mu p, is 40 centimeter square volt per second, and for the PMOS NMOS, the threshold voltage is 1 volt and the mobility of the electrons is 300 centimeter square volt per second. So we have to find out the output voltage. So this one is very simple question. So, but we have to know about the concept. So first of all, I want to just mention the important terminal, that is our this one. I am saying this is a G of P, gate of the P terminal, and this terminal is our source of P. Okay, and this one we can say D of P, and this one is also the drain of N terminal, gate of N terminal, and source of N. Arrow signal always shows the source connection. So okay, so this one are the thing. Okay, so now first of all we have to write the given thing. What are the given things are there? So W by L of Pmos. So I am writing as P. Okay, it's 5 is given, already given the threshold voltage. So VTP is 1, or one can write VTP equals to -1 because threshold voltage of PMOS will be negative. Okay, and the other term, that is our whole mobility, that is our, simply we can write mu P is 400 centimeter square volt per second. This one for the PMOS data. Now similarly the other one we have to write L for the NMOS is 1, VTN is 1 volt. Okay, so better to put volt here. And electron mobility is mu n. So it is 300 centimeter square volt per second. So there is a mistake. Always the electron concentration, electron mobility will be higher. This one is only 40 centimeter. So mu n will be always higher than mu p. Okay, this data for the Pmos and this one for the Nmos. Now the next thing that we have to, and we have to find what we output. We have to find the V output value, and the option is equal to 0 volt, less than 2 volt, more than 2 volt, and equal to 2 volt. Okay, so then after, what we can say, we have to identify in which mode the circuit transistor is operating. For NMOS, suppose we are just considering for N MOSFET. Okay, it may be either saturation or cutoff. Okay, so to identify this one, here the gate and drain is sorted. Okay, so when gate and drain is sorted, it is in the saturation mode. Saturation mode, or we can easily identify this concept how saturation mode, because if we have to know the characteristics of what we can say the NMOS. I am just giving some simple theory. So this one is our ID one, ID curve, ID, and this one is VDS, and this one is a VGS minus VT. So this VDS is greater than equals to VGS minus VT. It is in the saturation. Okay, and when the VDS is less than equals to VGS minus VT, it is in the linear mode of operation. Okay, this one is our saturation. I'm just giving some theory also, and linear mode of operation. Okay, so now I have already the gate and then is sorted, which is saturation. So it will very easy to identify, because in both the case gate and drain are sorted and source is grounded. So I am just using this one. So VD minus VS, we can write VG minus VS minus VT. So this source is same. So, okay. So VD is greater than VG minus VT. In our question, VD equals to VG because both are sorted. So this VD will be always greater than Vg minus Vt. So it is always in the saturation when gate and drain are sorted. When gate and drain are sorted, so one is we have identified, so similarly the other one is also in the saturation region. So most of the time you just think about the Nmos and we can easily think that okay. So this one is in saturation region. So now the current flowing, I'm just using color green color here. This current, that is our, I am saying IDP, that drain current due to P, and this drain current due to Nmos in Nmos will be same. Okay, because there is no connection outside, so all current is going from supply to ground. So we can say the IDP equals to IDN, and both are in saturation. ID, and so I am writing saturation as a SAT. Okay, clear? Now what we have to write? Now we have to write the equation for the Pmos and Nmos, or again one more line. So before that, I am just doing ID and okay, better to write full saturation, the same equation, because there will be no confusion. ID P in the saturation, the same equation. Okay, and then after we have to write the equation for the drain current. So drain current equation of a Nmos is 1 by 2 mu n COX W by L of n, we can write VGS of n minus VT n whole square. Okay, the saturation current in a Nmos. Now we have to write carefully the saturation current in the Pmos, drain current equation. So 1 by 2, we can write mu P COX W by L of P, that is our Pmos. And then after, what we have to write? Here get to source. In this case, we have to write source to gate of P minus mod VTP. Okay, then after it should be whole square. So this one is important. So we have to very careful. Just interchange S and G. Okay, and minus VTP. Okay, so this one is the equation, and in the question it is given COX COX, I'm writing COF. Okay, of Nmos and COX of Pmos are same, equal. So we can directly cut this COX, COX term, 1 by 2 term we can directly cut out. Okay, now again I am writing W by L of N. We have known to us W by L of N is our 1. So one can write simply 1 into, now I am breaking this one, VGN minus VSN minus VTN whole square. We are just adding VGS equals to VG minus VS. Now it is for Nmos, so we can write VGN VSN. The same thing I am writing here. W by L of 1, W by L N is 1. Then we have to write, okay, and one mu n term is there. So we have to write into mu n term is there, so don't forget. Then after W by L of P, W by L of P is given 5. Okay, so 5 into mu P. Okay, 5 into mu P I have already written. Then after VGS, so sorry, VSP minus VGP minus VTP whole square. Okay, now one more thing, we have to very careful about this type of calculation. Okay, because if our concept is okay but calculation is wrong, so our answer will be wrong. So mu n the value is in 300 centimeter square volt second. So I am writing here 300 centimeter square volt per second. Okay, W by L is given 1 unit less. Okay, now then after VGN. So in this case, we can say the VGN value is same as that of V output, and VSN equals to 0 because it is connected to ground. Okay, so this one is very important because we have to use this term, this value get of n. So directly I am writing get of n is nothing but simply our, I'm taking blue color. So VGN is our V output minus 0, so write 0, and VTN is minus 1 whole square, and here we can write 5 into mu p is value is given, that is our 40. Okay, now mu p value is 40, so wait, better to write 40 centimeter square volts second. Okay, and then we have to take care of VSP. VSP, that is our VSP is our plus 4 volt. Okay, and VGP I am writing here. VGP is V output. This VGP is V output. This one is also very important. So we have to, okay, VG was VGP is our what, V out, and VSP the source voltage is our 4. Okay, so one can write 4 minus VGP, already we have calculated our V output term. Okay, and minus mod, so it should be 1 whole square. Okay, now we have to solve this one to find the value of V output. So we are just cancelling centimeter, unit become unitless. So then after we can write 300, one more line I want to write V output minus 1 whole square into 200, then 3 minus what? V output square. Okay, so this one is the, then this double zero will be cancelled, and then we have to solve this one. Okay, so if we solve, so better first break it. V out square plus 1 minus 2V output equals to 2, then 9 plus V output square minus 6V out. Okay, so I am not skipping any step. So again, 3V out square plus 3 minus 6 V output equals to 18 plus 2 V out square minus 12 V out. Okay, now just put the right hand side in the left hand side, so we can directly write V output square, then it should be plus 6V out. Okay, then 3 minus 18, so it should be minus 15. Okay, V output square plus 6V out minus 15. So this one is the quadratic equation. Okay, so now we have to use the concept of quadratic equation to solve this problem. So V output equals to minus B, so I am writing directly minus 6 plus of minus B square. So B square is our 36 B square minus 4 A value is 1, and this one is minus 15 by 2A, so 2 into 1. Okay, so it should be minus 6 plus minus, just we can write 36 plus 60 by 2, or we can write more line, one more line, 60, then it should be 96 by 2. So okay, if we solve this one, root over 96 is nearly equals to 10, or it is approximately the value of root 9 is 9.8 by 2. So we output one value, one can write minus 6 plus 9.8 by 2, and the other value of we output 2, because there are two root, so minus 6 minus 9.8 by 2. So now there are two value, so minus 6 plus 9.8, so it is 3.8 by 2. So I am writing 3.8 by 2 is 1.9 volt. Okay, unit we have to write. Then it should be 9 and 6, 15.8. Okay, minus 15.8 by 2. So it will be minus 7.9 volt. So okay, so now we have to decide which one is correct. So V output value, there will be 7.9 volt because the supply is 4 volt. Okay, so this answer will be wrong. So the correct answer will be 1.9 volt. We output 1. So in our option, okay, in our option, V output is our coming 1.9. So which one is the correct answer for this question? Equal to 0, wrong. More than 2 volt, wrong. Less than 2 volt is the correct answer. Okay, and equal to 2 volt is also wrong. So the correct, okay, so the correct answer for this question is 2, less than 2 volt. Okay, less than 2 volt. Okay, so this is all about this question, but we have to very careful about the concept, how to write the drain current equation, and which region it is in saturation or linear. So this is all about this question. So thank you for watching this video.